Number 1. As the roller coaster begins descending a hill as shown in the diagram, your body feels like it is being pushed hard into the back of your seat. Which of the following is the correct explanation for this sensation? A. The roller coaster track applies a force on you that pushes you back into your seat as you go down the hill. B. The force of gravity pulling you down makes you feel like you are being pushed into the back of your seat as the roller coaster accelerates down the hill. C. As the roller coaster moves down the hill, it makes your body move with it, and your body resists changing its motion, which makes you feel like you're being forced into your seat. D. The roller coaster car you are in has more mass than you, so it moves faster down the hill, leaving you behind and pressing you into your seat. Number 2. According to Newton's second law of motion, the relationship between an object's mass, m, its acceleration, a, and the applied force, F, is F equals m times a. How does this law apply to the sport of bowling? F. When the pins are correctly aligned, their mass and acceleration will keep the ball from going into the gutter. G. When the bowling ball is rolling down the lane, the mass of the ball on the floor makes the pins become unstable, allowing the acceleration of the ball to knock down the pins. H. When the bowling ball is rolled with the force, this accelerates the ball so that it has a high velocity when it hits the pins. J. When the bowling ball hits the pins, the ball has a mass, so it will exert acceleration on the pins and knock them down. Number 3. The picture above illustrates the horizontal force acting on a car. The car's engine force pushes forward, while friction between the tires and the road, along with wind resistance, drag at the car in the backwards direction. Which of the following must be true about these forces if the car is driving forward on a level road at a constant speed of 45 miles per hour? A. The force of the engine forward must be greater than the force of the gravity acting on the car. B. The force of the engine forward must be greater than the combined forces of friction backward. C. The force of the engine forward must be less than the combined forces of friction backward. Or D. The force of engine forward must be equal to the combined resistance forces. Number 4. Which of the following best illustrates an application of Newton's first law, also called the law of inertia? F. A passenger not wearing a seatbelt is ejected from an automobile during a severe crash. G. Dinner plates remain on a table when a slick tablecloth is pulled out from underneath them. H. An ice hockey puck continues sliding across the relatively frictionless ice until it comes into contact with a wall or a player's stick. Or J. All of these are examples of Newton's first law. Number 5. The image models the process of Pangaea breaking up into modern-day continents. Which of the following best explains why Pangaea broke apart into modern-day continents? A. Earthquakes and volcanoes form between the continents. B. Changing climate caused ice to form between the plates. C. Balance forces caused a change in the motion of the plates. Or D. The plates underlying the continents were already in motion. Number 6. The diagram below shows the different forces acting on a toy rocket. The total mass of the rocket is 0.5 kilograms. Based on the information above, what is the acceleration of the rocket? F 6, G 30, H 14, or J 46? Number 7. You are riding in a vehicle with a coffee cup on the dashboard while traveling 30 kilometers per hour. The vehicle makes a sudden stop to avoid hitting the car that has stopped in front of it. Which illustration best demonstrates what would happen to the coffee cup? A. Go forward. B. Go backward. C. Stay stationary or not moving. Or D. Go straight up. Number 8. Which of the following statements is correct regarding the speed and velocity of an object? Number 1. An object's speed is determined by the distance the object traveled and how long it took the object to travel that distance. Number 2. An object's velocity is determined by the distance the object traveled, how long it took the object to travel that distance, and what direction the object traveled. Number 3. An object's velocity is determined by the distance the object traveled and how long it took the object to travel that distance. Number 4. An object's speed is determined by the distance the object traveled, how long it took the object to travel that distance, and what direction the object traveled. Which of the following statements is correct regarding speed and velocity? F. 1, 3, 4 only. G. 1 only. H. 2 only. Or J. 1 and 2 only. Number 9. A local school activity bus travels north to Denton to take students on a tour of the University of North Texas. The trip from the school to Denton is 66 kilometers. The bus travels for 56 minutes before it arrives at the UNT campus. Which of the following best represents the speed of the bus for this campus visit trip? 1.18 kilometers per minute north, 2.0 kilometers per minute south, 1.2 kilometers per hour, or D, 1.18 kilometers per minute. Number 10. How are speed and velocity different? F. Speed includes direction. G. Speed indicates momentum. H. Velocity includes momentum. J. Velocity includes direction. Number 11. The two teams are competing in a game of tug-of-war in the diagram below. Both teams are pulling with a force of 2,300 newtons. What will happen if the team on the left makes an extra effort and pulls the rope with a force of 2,330 newtons? A. The team on the left will be able to pull the other team to the left at a constant speed. B. The team on the right will be able to pull the other team to the left at a constant speed. C. The team on the left will be able to pull the other team to the left at an increasing speed. Or D. The team on the right will be able to pull the other team to the right at an increasing speed. Number 12. On the moon, an astronaut jumps a farther distance with more speed than he would on Earth while exerting the same amount of force. Why did the astronaut jump this way on the moon as compared to on Earth? F. The force of gravity on Earth is less than the force of gravity on the moon, causing the astronaut's net downward force to be greater on Earth. G. The force of gravity on the moon is greater than the force of gravity on Earth, causing the astronaut's net downward force to be greater on the moon. H. The force of gravity on the moon is less than the force of gravity on Earth, causing the astronaut's net upward force to be greater on the moon. J. The force of gravity on Earth is greater than the force of gravity on the moon, causing the astronaut's net upward force to be greater on Earth. Number 13. When an object is acted on by unbalanced forces, the object will A. Accelerate, B. Continue in the same direction, C. Continue at the same speed, or D. Come to a stop. Number 14. A student pushes a box with a force of 16 newtons to the left. Another student pushes the same box from the opposite side with a force of 8 newtons to the right. According to the above information and diagram, what will be the result? F. The box will move to the right with 8 newtons force. G. The box will move to the right with 24 newtons of force. H. The box will move to the left with 2 newtons of force. J. The box will move to the left with 8 newtons of force. Number 15. The graph below represents the movement of an object. Which description best fits the motion shown on the above graph? A. An airplane taking off and reaching a constant cruising speed. B. A roller coaster traveling up and down the first hill. C. A car traveling at a constant speed and stopping to refuel. D. A roller coaster traveling down a hill and climbing the next hill. Number 16. A 2,000 kilogram truck and a 500 kilogram car are racing. The same amount of force is applied to each of them. Which statement below describes the acceleration? F. The truck will accelerate twice as fast. G. The car will accelerate 4 times as fast. H. The car will accelerate twice as fast. Or J. The truck will accelerate 4 times as fast. Number 17. One of the laws of motion states an object in motion stays in motion unless an unbalanced force acts upon it. On Earth, objects always seem to eventually come to a stop when more force is not being applied. What force is causing the objects to eventually stop moving? A. Mass. B. Friction. C. Weight. Or D. Gravity. Number 18. The diagram below shows a barge moving north at 5 meters per second, while the current in the river is moving south at 1.34 meters per second. When the barge enters the northernmost part of the river, the southward current is 0.67 meters per second. How will the barge be affected? F. The barge will move slower. G. The barge will move faster. H. The barge will come to a stop. Or J. The direction of the barge will change. Please make sure your name and period are on the test and you've answered all the questions.